Welcome to the long division podcast. This was the material that we learned in class today. So first of all, if you were absent, taking the PSAT or just absent, this is the whiteboard practice problems. I will post them. I would like you to complete these. Right, the A and C here, you'll use greatest common factor and then factor by grouping for quadratics. And then B and D over there, you use factor by grouping. Okay. All right, so what are two ways to find the x-intercepts of a polynomial function? All right, we learned two different ways. One of those was factoring out the greatest common factor, okay? And then we factored the remaining quadratic. And then number two was factor by grouping. And sometimes we also had to factor the difference of squares. Now, these methods are great. They're very efficient. They're not too difficult. The problem is they don't work all the time. So these methods don't work all the time. Both involve a greatest common factor. Either a single monomial, and that would be true for when we're factoring out a greatest common factor. We have some common monomial factor, or a binomial expression. And factor by grouping, we have a common binomial expression. Right? And we find that using factor by grouping. When no such common factor exists, we need another solving technique. Before you can learn another solving technique, however, you need another tool in your toolbox. And that tool is going to be long division. So we're going to be able to use another method when we can't just factor out a greatest common factor or when factor by grouping doesn't work. All right, so if you remember, and actually I'm going to close up part of this screen. There we go. If you remember back when you were in maybe 4th or 5th grade, you learned how to do long division with numbers. Right? So remember how you used long division to divide whole numbers as shown at right here. Right? So if I'm dividing 345 by 23, I just look at the first two numbers. Right? I looked at the 34. And I say, how many times does 23 go into 34? Right? So I divide. Okay, so 23 divides into 34 one time. Okay? And then I multiply. 1 times 23 is 23. And then I subtract to see what's left. Okay, so I have 11 left. That's too small. I can't divide 23 into 11. So we bring down that other term. We bring down the 5. Now I have a large enough number I can divide into. 23 divides into 115. That goes in 5 times. Then we multiply. 5 times 23 was 115. And then we subtract. Oh, here we don't have any remainder at all. So that means that 23 is a factor of 345. And 15, the answer, is also a factor of 345. So because the remainder is 0, 23 and 15 are factors of 345. We're going to do basically the same steps, but we're going to do them with polynomial equations. So here we're going to divide x squared plus 3x plus 2 by x plus 2. All right, so when I'm dividing, just like when I only looked at part of the number up above, I'm only going to look at part of the equation. I'm only going to look at the leading terms. I'm going to look at the x, and I'm going to look at the x squared. And as we go through, I'm going to have a different leading term, right? Because when I subtract, I'm going to then work with the remainder. So let's take a look. This one's all done. All the other ones I'm going to do step by step with you. So instead of thinking of how many times does x divide into x squared, I like to think of it as, what would I have to multiply x by to get x squared? And I'd have to multiply x. right? X times x would give me x squared. So notice I only deal with the first two terms. However, when we multiply by the whole binomial. But to figure out our quotient, we're only going to work with one term at a time. Right? So x times x gives us x squared. X times 2 gives us 2x. And then we subtract. Remember, when you're subtracting, that means to add the opposite. If you don't remember to add the opposite, you may have a sign error. Number one mistake students make is forgetting to distribute the subtraction sign to all the terms. So 3x minus 2x gives me x, and x wouldn't be enough, so I'd have to bring down another term. Right? So what would I have to multiply x by to get x? Now I'm only going to look at that leading term. Well, I have to multiply x by 1 to get x. Right? So we put a plus 1 there. And then 1 times x gives us x. 1 times 2 gives us 2. And then we subtract, which means to add the opposite. X minus x is 0. 2 minus 2 is 0. Okay. So because the remainder is 0 here, x plus 2 and x plus 1 are factors of x squared plus 3x plus 2. Now this one, we didn't have to necessarily use long division, except that's my whole goal, is to teach you long division. This one we could factor. So let's factor it just to show you that those really are the factors. Right, so if I have x squared plus 3x plus 2, right, a times c, 1 times 2 is 2. Two numbers that multiply to give me my product of a times c, and add to give me my b term are going to be 1 and 2. Okay. All right, so I have x squared plus 2x plus x plus 2, and the first two are a group, and the second two are a group. We'll factor out an x, and we're left with an x plus 2. Factor out a 1, we're left with an x plus 2. Right? And then what we pulled out is one factor. The repeating x plus 2 is the other factor. And notice we get the exact same factors as we got using division. Right? So we're going to learn how to use division to be able to factor. We're also going to use division just to be able to divide one polynomial into another. That will be a useful skill in many classes. All right, let's look at this one. All right, so this time I'm going to do the whole thing with you. Our steps are to divide, multiply, subtract, bring down, repeat, just like you would do if this were long division with numbers. All right, x plus 3 is what we're dividing by, so that's going to go, if you will, outside the house here, outside the division symbol. And x squared plus 10x plus 21 is inside. I only deal with the leading terms. So what would I have to multiply x by times x is x squared. All right, so now I do step 2, I multiply. X times x is x squared. X times 3 is 3x. And now we subtract, which means to add the opposite. X squared minus x squared is 0. I don't need to write that down. 10x minus 3x is 7x. And now I don't have enough terms. I need to work at 2 terms at a time. But we only think about the very first term, the leading term, because that's the one we have to match. We have to make sure there's no leftovers on the leading term. Otherwise, we didn't choose our greatest divisor. All right. So what would I have to multiply x by to get 7x? I have to multiply x by 7. Right? 7 times x is 7x. 7 times 3 is 21. And then I subtract, which means to add the opposite. 7x minus 7x is 0. 21 minus 21 is 0. So no remainder here. And because the remainder is 0, x plus 3 is a factor of x squared plus 10x plus 21. And of course our answer, x plus 7, is the other factor. Sometimes the divisor is not a factor of the dividend, so the remainder is not 0. Then the remainder can be rewritten as a rational expression. All right, so we want to divide 3x squared plus 19x plus 26 by x plus 5. X plus 5 is going to go outside the house. 3x squared plus 19x plus 26 is inside. So what would I have to multiply x by to get 3x squared? I'd have to multiply it by 3x. 3x times x is 3x squared. 3x times 5 is 15x. And then we subtract, which means to add the opposite. 3x squared minus 3x squared is 0. That one has to be 0. 19x minus 15x is 4x. I need two terms, so I'm going to bring down the next term. So that's a plus 26. And then I ask myself, what would I have to multiply x by to get 4x? I'd have to multiply by 4. 4 times x is 4x. 4 times 5 is 20. And then we subtract, which means to add the opposite. 4x minus 4x is 0. 26 minus 20 is 6. And so now we have a remainder, which means that x plus 5 is not a factor. Our answer is the quotient, which is 3x plus 4, plus the remainder, which was 6, over the divisor, which was x plus 5. And there we go. There's our answer for this one. There will be times when we need to be able to rewrite an equation as its quotient and the remainder. Okay? All right, let's look at the next one. All right, so we're going to divide, and this one, by the way, is in your notes. All right, so we're going to divide x cubed plus 5x squared minus 3x minus 4 by x plus 6. All right, so I ask myself, what would I have to multiply x by to get x cubed? I'd have to multiply it by x squared. X squared times x is x cubed. X squared times 6 is 6x squared. Right? And then I subtract, which means to add the opposite. X cubed minus x cubed is 0. 5x squared minus 6x squared is a negative x squared. And then we bring down our next term. Right? What would we have to multiply x by to get negative x squared? We'd have to multiply it by negative x. Negative x times x is a negative x squared. Negative x times 6 is negative 6x. And then we subtract, which means to add the opposite. Negative x squared plus x squared is 0. Negative 3x plus 6x is 3x. And then we bring down, we need two terms, so we bring down another term. All right, so we're going to divide x plus 6 into 3x minus 4. Well, we have to multiply x by to get 3x. Right, we'd have to multiply it by 3. 3 times x is 3x. 3 times 6 is 18. And then we subtract, which means to add the opposite. That would give us negative 22. So notice we have a remainder here. Right? So since x plus 6 is not a factor of x cubed plus 5x squared minus 3x minus 4, since there's a remainder. Right? And so our answer is x squared minus x plus 3 plus x plus 6 over, oh, excuse me, negative 22, sorry, I'm looking at the wrong thing, plus negative 22 over x plus 6. Actually, let me write that in. I had this in earlier, so I just want to make sure, oops, well, that's kind of stuck together. That's okay, so don't write this yet. Let's write our rule here first, so you have that somewhere in your notes. So your answer is your quotient plus the remainder over the divisor. And so for this problem, our answer would be x squared minus x plus 3 plus negative 22 over x plus 6, because that's our divisor. Okay, and that's all there is to it. Right? Long division, very important skill. So I'm going to save. One class did one problem, this problem, the other class did. I'm going to save this one for class because I think I'm at a good time. So we'll pick up with this problem here. All right, and if you have any questions, ask me in class. There was no closing for today, right? So there's no closing to make up. All right, so see you tomorrow.